Hey learners, hope you all are doing well. In the previous lecture, we discussed different data types provided by Python. In those all data types, we saw all elementary data types. Today, we are going to discuss how these elementary data types are stored in memory. That is, in short, we are going to discuss memory allocation strategy or memory management strategy of Python. In this topic only, we'll be making clear the concept of mutable objects and immutable objects. Now, take an example. If suppose I've created variable x equal to 10. Now, what will happen is there is a symbol table created internally. Memory will be allocated to store 10, and the address of that 10 will be recorded in this symbol table. So as I have shown pictorially, memory is allocated, 10 is stored there, and its address will be recorded in this symbol table for x. But now suppose if I create one more variable y equal to 10. Now you can see the value assigned to y is 10 only. So that is the speciality of Python. It will not create another memory for this 10. Instead, this y will also refer to the same memory which was allocated for this 10. Only a new entry will be done in the symbol table. See here, pictorially I have shown y is entered as a new entry in the symbol table, but it is referring to the same memory location. Whereas in some other languages like C, C++, and Java, all these elementary types, for each value separate memory is allocated, though the value is same. That indicates they are mutable. That is, the objects can change. Whereas here the objects don't change. Instead, new object is created. That indicates it is immutable. Now suppose after some time, if I write x equal to 15, so as the value assigned to x is 15, now the memory which was allocated previously for x, in that memory, the 10 is not going to get changed to 15. This indicates it is immutable. Rather, new memory is allocated. In that 15 is stored and the new address is recorded in the symbol table. So I have shown here pictorially a separate memory 15. Then the address of that 15 is recorded in the symbol table and the previous address is lost. But still y is referring to that 10. Now suppose after some time, if y is assigned value 25. So previously y was assigned 10, but now y is assigned value 25. Now new memory is created. This new memory address will be recorded in the symbol table for y. The old reference is lost, and as to this memory there is no reference present, means the ref count for this memory is lost. It is garbage collected. This garbage collection, you don't have to worry. Python takes care of it. That is, Python virtual machine takes care of this internal garbage collection. So I guess you got the concept that if two variables are having same value, they will have same address. Whereas in other language, though the variables have same value, their address will be different. This indicates all the primitive values like string, int, float, boolean, complex. They all are immutable. That is, the objects cannot be changed. Rather, new object is created. Now to prove this, I'll show you some demonstration here. Python has provided one function called id, which will give the address of variable. Now suppose if I write x equal to 10 and again I write y equal to 10 and I try to print their address. See, print id of x comma id of y. Can you see both the variables are having same address? This justifies that when two variables have same value, their addresses will be also same. Now suppose if I try to make x equal to 15 and now try to print both the address. Now you can see x address is changed and y address is the previous one only. I guess this is clear to you. Now let's move on to the next concept, that is typecasting. Now next topic which we are going to discuss is typecasting. Typecasting means conversion of value from one data type to another data type. Casting can be done implicitly also as well as explicitly. Now implicit casting means casting which is done by the interpreter as needed. Means programmer doesn't have to do that casting. But when the casting is done by the programmer, then we'll say it as explicit casting. So I guess what is casting is clear to you. Typecasting means conversion of value from one data type to another. Clear? It is somewhat similar to casting in movies and serials. The actors and actress are casted for that serial. Means they are going to just get converted into that role for that serial purpose or for that movie purpose. But when the movie is over, that casts are again back to their original role. Now we are going to discuss how to do explicit casting in Python. Python has provided some casting functions that I'll be listing now, and then we'll discuss all those casting functions. So typecasting is the conversion of data type from one to another. We will use following 5 inbuilt functions for typecasting through the Python code. First is int. This is to convert any other type to integer. Float. This is to convert any other data type to float. Complex. Similarly, to convert any other data type to complex type. Any other data type to Boolean. And any other data type to string. We'll discuss all this one by one. First, we'll discuss about int. Int is for converting any other type to integer. But there are some restrictions, like complex type cannot be converted to integer. That is Python limitation. You cannot convert complex to integer. And you can convert string to integer, but the string should contain numeric value. That is a integer or a float in a double quote or a single quote. But that string should contain numeric value. And it is very legal to convert Boolean to integer. But some strict type languages, that is Java, it doesn't provide such facility. So let's discuss about this. We use this function to convert any type into integer type value. As I already stated, we cannot convert complex type into integer type. It becomes an exception. Remember, Python is also very robust like Java. In Python also, if there is unusual thing happening, it will throw an exception. And then how to handle those exceptions, we'll be discussing it in exception handling chapter. Also, if you want to convert any string value to integer, I already stated the string should contain integer. Otherwise, it will raise an exception, that is value error. As an illustration, suppose I'm converting 12.35 to integer. So 0.35 will get truncated and you'll get an integer 12. Now I'm converting string to integer, but in that string there is 1 2 3, so it will convert it to integer 1 2 3. Converting Boolean true to integer, and true is internally 1. Similarly, I'm converting a complex value to integer. As already stated, complex conversion is not allowed, so it gives a type error. But this is not a type error, this is value error. Why? Because string is legal to get converted into integer. but inside that string there should be int value. So as string is allowed to get converted, but inside that string there is an invalid value. Therefore, it is a value error, not a type error. But here in this case, why type error? Because complex is not allowed only to get converted into integer. Let's see the next conversion function, that is float. Float is used to convert any type to floating type. The similar rules are applicable, which we saw for int. Complex type cannot be converted to float. Booleans and integers can be converted to float. String also can be converted. Again, string should contain a numeric value. Use this function for converting other types into float type values. We cannot convert complex type into float. Also, the string should be in decimal form and contain only the integral or floating point value. As an illustration, I'm converting 12 to float. The 12 is integer. It is getting converted to float, so it will become 12.0. Conversion of true to float. So true internally 1, but when we convert it to float, it will become 1.0. Now this string contains 123.5, which is a legal integer value, but inside a string, so it will get converted to float 123.5. Double quote 10 will get converted into 10.0. But now string double quote, in that there is word ten. The string is legal for conversion to float, but the value is not legal. Therefore, it gives a value error. Similarly, if I'm trying to convert 3.3 plus 5j, which is a complex value, here it doesn't give value error, it is a type error because it is illegal to convert a complex to float. Then we'll see complex function, conversion of any other data type to complex type. Now here, what all things can be converted? You can convert int to complex, float to complex, boolean to complex. String also can be converted to complex. How the rules are, that I'll tell you. This function is used to convert other types into complex data type. There are two ways in which you can use this function. The first one with only one argument, complex x. But if you use this one, x will act as a real part and the imaginary part will be 0. And suppose if you use this one, complex x comma y, then that x will act as a real and y will act as imaginary. For example, complex of 10. So 10 is integer. It will get converted to complex, but 10 will become real and imaginary part will be 0j. Complex 10.5. So 10.5 is float, but when converted to complex, it will become real. Here also the imaginary part is 0j. True, which is Boolean. Now Boolean converted to complex. True value is 1. 1 will become real. Here also the imaginary part is 0j. Complex 108 in string, that will become real and imaginary part is 0j. 10 comma minus 5. So 10 is real and minus 5 will become imaginary. True will become real and false will become imaginary, but their internal values are 1, 0. So the new complex value is 1 plus 0j. Note, in case of string, it should be integral value within quotes. Next conversion function is Boolean. This is to convert any other type to Boolean. Now there is no such restriction who will get converted to Boolean. All values can be converted to Boolean. So it is used to convert other data types into Boolean type. Now what are the rules for Boolean true and Boolean false? Integer 0 is treated as Boolean false and all other value other than 0, that is all non-zero values, are true. Same is the case for float. Float 0 is false and all other floating values are true. For case of string, if the string is empty string, then it is Boolean false. Otherwise, it is true. And if it is complex value and you're converting it to Boolean, then both the real part and the imaginary part should be 0. Then it is false. Otherwise, 0. Let's recall this all points. If x is integer and if the value is 0, it is false. All non-zero meaning true. X is float, and if that value is 0, then false, else true. X is complex and both the real part and the imaginary part is 0, then it is false, else it is true. If it is a string, but that string is empty string, then it is false, else it is true. As an illustration, I'm converting integer 0 to Boolean, it is false. Integer 5 to Boolean, it is true. 0.2, which is true. 0.0, it is false. 0 plus 5j is true. Why? Because a complex value is false only when both the real part and the imaginary part are 0. 0 plus 0j, as both real and imaginary are 0, it is casted to Boolean false. Empty string is casted to Boolean false. String which is containing something, so when you cast it to Boolean, it becomes true. Then we'll see one last conversion, that is string, converting any data type to string type. We use this to convert other data types into string data type. Whatever argument is passed, it just codes it and makes a string. Always remember, it will return a new object. The given values will remain as it is. It will convert it into string and return it as a new object. Now I am converting integer 10 to string. It will become quoted 10. True converted to string, so it will become double quote true or single quote. 8 plus 9j, it's a complex value converted to string. We discussed this 5 conversion functions, that is integer, float, Boolean, complex and string. That's all for today. As usual, keep watching, keep learning, keep evolving. Do subscribe, like and share with your friends. In the next session, we'll discuss about different operators which are provided by C.